My guest today is Professor Missy Cummings, who's Professor of Electrical and Computer Engineering at Duke University and the Director of the Humans and Autonomy Laboratory and Duke Robotics. Her research interests include human-unmanned vehicle interaction, human autonomous system collaboration, human systems engineering, public policy implications of unmanned vehicles, and the ethical and social impact of technology. Welcome, Missy.
Thanks for having me.
Yeah, thanks for doing this. So I want to start with one of your recent papers, Rethinking the Maturity of Artificial Intelligence in Safety Critical Settings, in which you say while AI has recently been touted as very successful across a number of domains, including transportation, medical applications, and digital personal assistants, the reality is that such systems may not actually be as capable as envisioned, is slowly creeping into the national consciousness. I know that autonomous cars have really taken off. Everybody's buying them. We had some bad news come through last couple of years, a few bad news, I should say. So where do we stand on these, as you call it, mission critical systems like transportation?
In terms of where do we?
In terms of safety, in terms of their practicality, so to speak.
Well, if we're going to talk about transportation systems more broadly, I would say we're in still a very early nascent stage of incorporating any kind of real, quote unquote, real AI. And by real AI, I mean any kind of reasoning on the part of the computer-based system to actually take action and move the vehicle through space. But, you know, that's kind of a broad brush. I think you have to look at the different transportation domains separately. So, for example, some very low-level artificial intelligence has been around in aircraft for a while if we want to talk about forms of path planning, you know, how to do more optimal routing. That's been pretty effective in aviation for a while. It's not part of a safety critical system. It's really an advisory system, which is why it's been working so well. And it's very low level AI. But if we want to talk about high degrees of artificial intelligence and something like computer vision, then that's really happening significantly more in the surface transportation, cars, trucks, for example. And we know for a fact, indeed, the most recent release of Tesla's full self-driving has illustrated really just how far away we are from having cars that can reason under uncertainty in these surface transportation settings.
Yeah, as you say, airplanes have been using, well, this is where the confusion is. There are rules-based systems, used to be called expert systems. My thesis in the mid-'80s was one of the first expert systems in education at Northwestern, where we tried to learn sort of cognitive bias patterns of students, graduate students, and use that to guide them to reach optimum designs. But these were really looking for rules and implementing rules. And they have been around from the inception of computers. So nothing really has changed there. People have gotten very excited because of cheap computing power recently, but fundamentally nothing has changed there. But then we have this deep learning revolution going on. Again, 60s technology, neural nets, some nice mathematics, and again, cheap silicon has made it more interesting. And so when you say AI, do you mean the latter variety?
Well, I think that you're raising this issue of the different flavors of AI is really important. In the academic circles that I move in, we separate AI into two different camps, symbolic and connectionist. And symbolic is just what you were talking about, expert-based systems. So, you know, I think of these as rule-based systems. If some set of conditions happens, then I can execute some set of rules. And indeed, we often use heuristics, some shortcuts, shortest distance, for example, to help us do that. So symbolic AI has been around a long time. Connectionist AI is kind of what it sounds. It's connecting these different components. And this is, where we start to hear about neural nets. I remember learning about artificial neural nets back in the early 2000s and thinking, oh, this is never going to go anywhere because it's so, learning the weights. There's no real science behind it. It's really just learning pattern recognition. And indeed, I've been using neural nets in my research for my entire career, but boy, was I wrong, right? I was wrong because this idea that neural nets replicate the neurons in your head and that somehow there are all these connections that are mimicking intelligence, while I've never thought that was a huge leap, it is actually, I have found to be very compelling for people who aren't deep researchers. And so I hear this all the time, that neural nets replicate what is happening in the brain. And that could not be further from the truth. But because it's a powerful metaphor, I think that this is the reason that we've seen deep learning take off in these really amazing ways. And this is not to say that it's not a useful technology. There are some really awesome uses of deep neural nets. My favorite are the artificial noses, right? We can start detecting patterns in smell detection that we can't really do in the real world because we have no good models for this, right? So connectionist AI works really well when we do not have models that can even come close to replicating what we're seeing in the real world. But this is known as model-free learning, right? And so that can only take you so far in the world, especially when there's a lot of uncertainty in the world.
Yeah, uncertainty is always a problem. And so, I mean, one could look at deep learning as sort of a statistical process where we don't really have heuristics, but we have a lot of historical data. And we could sort of in a lazy way come up with a statistical heuristic because we now have cheap silicon and cheap memory. And I think this is one of the issues. Companies in Silicon Valley, for example, large companies are sitting on billions of dollars on their balance sheet, and they got religion on deep learning. And they are going down the path without looking side to side, saying, put more silicon on it, just get a more and more complicated neural nets. I heard somebody say recently that there is nothing deep learning cannot solve. There's nothing, he said. And so do you see this as a problem that we got enamored by something and then we are just heading down that track, assuming that it's going to solve everything?
Oh my gosh, don't even get me started. The people who say that they can replicate, if they had all the data in the world, they could replicate all the relationships in the world. No, you can't. No, you can't, because neural nets are a human construction. And indeed, one of the areas of research that I'm working on is trying to show just how subjective and how many human judgments we make in the creation of AI. So when you take just a very basic neural network, and people can read this article that was recently published in the Journal of Data and Information Quality, you start to make a lot of choices about exactly what kind of neural net, what kind of model, what kind of hyperparameters you choose, how you split the data, how you test the data. It turns out that what many people think is a very objective-based mathematical approach to analyzing data, these statistical heuristics that you're talking about, they are just basically heuristics. And there are so many human judgments that are made, and we still don't really have any idea about how much these different judgments can skew the outcomes of the data. And indeed, in a very simple case, we showed how if you analyzed one transportation data set using slightly different heuristics, statistical heuristics, you could come out with extremely different answers, right? And so this is why we need to be careful about the tools. As scientists, I think it's great when we come up with new tools for analysis. But I think fundamentally where academia has fallen very short, and indeed I fault academia for industry's problems, because academia is not doing enough research in the area of self-assessment. Like, how do we know these neural nets are good? How can we put some kind of quality index score on the veracity of these outputs? Because as we see in computer vision, boy, yes, it works great when the world looks exactly like the images that the vision algorithm was trained on. But for example, if you've got a stop sign with a half an inch of snow on it, vision algorithms that were trained on regular stop signs with no snow on them can't recognize them. So when we've got technologies this brittle that end up in the hands of the everyday person and the public in safety critical systems like cars, that's where I start to really draw the line to say, look, this is a tool. It's still not quite, we don't fully understand it, and we need to be really careful where we implement this in the world.
Yeah, so the contrarian view might be, Missy, I want to get your perspective on this, is that humans are not necessarily great decision makers. So I can give you good examples from the business world and the finance world. We can demonstrably show humans are exceptionally bad at decision making under uncertainty. We assert we make good decisions, but we have no proof that's in fact true in the business and finance world. In fact, in hedge funds and trading, for instance, machines do a lot better than humans sitting in front of a computer. And so we have examples of machines doing better than humans under uncertainty, but that is not necessarily a mission critical world. But then if you go back to automotive autonomous driving use case, again, we have humans. I mean, we have so many accidents on the highways on a daily basis, and humans make them. And most of the airline disasters, and you used to be a fighter pilot, and so the details of this. Many of or I would say, large percentage of airline issues that we had before are related to human error. And so if you put these things together, are we maybe giving machines not enough credit?
So there's a lot of complicated issues kind of all tied into what you just said. So I think first I'd like to step back and say there are different levels of reasoning that humans and machines have to deal with. And I've written a paper about this. You can read it on my website, about skill-based reasoning, where you have to learn to, when we're talking about transportation systems, keep an aircraft in stable flight, for example, keep the car on the road in between the lines. And then once you have the immediacy of the world successfully figured out, then you can start to graduate to higher levels of reasoning, which coincide with increasing uncertainty in the world. So when we say humans are terrible reasoners under uncertainty, I'm going to fight back with you in a friendly way and say, oh, no, humans are actually very, very good at reasoning under high levels of uncertainty that machines simply cannot reason under. And that is because of our ability to imagine and run fast simulations. So the best example I can give you is Chesley Sullenberger in the Miracle on the Hudson, right? He was able to see with a dual engine flameout that he would be able to safely get the aircraft landed on the water. Now, maybe one day we could have AI that could have reasoned through that. I certainly am not ruling that out. I'm a futurist, and I believe that these things are possible. But under today's technology, we have no technology that could have replicated that circumstance. Now, that's the highest degrees of uncertainty with a lot of unmodeled variables. For example, I think it will come as a great surprise to most people is we still don't know how to model wind. Wind, turbulence on aircraft, there's still so many unmodeled variables in aviation, and that's actually a pretty mature field. So if you want to start thinking about autonomy in high degrees of uncertainty, like medicine. Oh my God, you were so far away from being able to include autonomy in medical systems because human bodies can carry so much variability just from one person to another. And so I think it's the variability of the unmodeled world that is actually the largest predictor of whether or not a human or a machine is going to be successful at the task. And so our humans in fintech, boy, I sit on a board of directors and I couldn't agree with you more. There is so much bad judgment that I see in the business world. But these are, I would put that at a low, low, low set of uncertainty, even though people who do day trading might say there's a lot of high uncertainty. But we can model the financial world very well with mathematical representations. And even though we think that there's a lot of uncertainty, indeed, you know, with the stock market, people have a anxiety over COVID and we see the stock market drop. So even there is some uncertainty, but for the most part, you can actually do very well at mathematical models. And in the business world, where I see human judgment start to run awry, is when it's hubris and ego. And I hate to start immediately getting sexist, but it's amazing to me how many men do not want to listen to advisors around them and feel it's almost like the American cowboy is, we're well entrenched in the business world, right? So I think that those sets of bad decisions stem from not humans' inability to cope with uncertainty. Indeed, I think we can cope well with uncertainty, but it's humans' inability at those lower levels of reasoning and to make sure that they're taking in all the data that they should. So I put fintech and transportation in two different worlds. I think that machines can be very good at what we call the dull, dirty, dangerous parts of a mission. And this was certainly true in the military. Instead of having a drone, humans do circles in the sky just waiting for a bad guy to come out of a building, for example, that mission is much better under a drone's purview, because the drone doesn't need to go to the bathroom, doesn't need to eat, can hold altitude, and can stay in the same place for a very long time. And indeed, even commercial planes today, they use a lot less fuel when humans are not flying them because the control mechanics are so small. So yes, there are times where humans can err, and we do bring in inefficiencies. Indeed, I'm a big fan of the joint approach. So humans remotely supervising drones, yeah, for the military and for cargo missions and many civilian missions, I think that is the best set of circumstances, where you let the machine do all the low-level flying, staying on altitude, staying on airspeed, saving fuel, and let the human, who can be remote and still make the kind of supervisory decisions that they need, be at that armchair quarterback position where humans do very well. So I think that we need to move away from the either or. It's either machines, or humans, and try to look at the and. How can we combine these two?
Yeah, that makes a lot of sense. I wondered in the AI world if there is sort of a design specification problem, because what I hear and see is AI specified as an engineering problem. But in fact, it's truly a decision problem, right? If you don't get good decisions, not all that engineering is really going to help much. And so there's a lot of focus on sort of the engineering aspects of AI, but I suspect very little on the decision side. So that is why perhaps when we try to translate that into real world, what we get is technology, but not practical technology. Do you agree with that?
Yeah, I might put it in a slightly different package. So I'm a systems engineer. That's what my PhD is in. And fundamentally, I see the problems with artificial intelligence as a lack of true systems understanding, because computer science systems engineers are not the same as traditional systems engineers. Systems engineers in computer science, for example, are the people who are supposed to get the software working with the hardware. You know, obviously that's a very important component, but real systems engineers in other communities, their job is to actually sit back and first think about what are the concepts of operation, you know, where are these systems going to operate? Who are they going to operate around? How are they going to operate? And then once you actually understand the space of the when, where, what, why, and how, then you look at, okay, so what are the requirements? First, let's specify what should this system do, at least at a functional level, and then start designing from there. I find that computer scientists and a lot of electrical and computer engineers, and I see this every day as a professor in that space, we just skip that process. We have a cool idea. This is very Silicon Valley. I'm gonna have a cool idea, and cars, self-driving cars, sounds awesome, so let's just start designing it. And instead of actually sitting back and going, whoa, wait a minute, like that means that the cars need to function in this space under all weather conditions, under, you know, drivers who are potentially distracted, under conditions where the internet is not always going to be available. I have to tell you, on a daily basis, I generally run screaming through my house because someone is claiming that we should use 5G to remotely control cars. I mean, this is the worst possible set of concepts of operation, because you never, ever, ever can have real-time control of any system if you have any kind of communications link. You know, that is safety critical. And so indeed, but by the way, no one listens to me because I'm usually screaming because a new company has started up. There's a new startup with millions and millions of venture capital of a business plan that I'm telling you has zero chance of happening. There is no way we can ever control cars through 5G. It's just never going to happen. But no one in Silicon Valley is listening to me, especially the venture capitalists. And so I think that that's a good explanation of, like, you know, what we need to do is sit back and do real systems engineering and start thinking about, okay, you know, are there some major issues here with our thinking inside the concept of operations that might prevent this system from happening? We're not doing enough of that. That being said, you know, there's a lot of VCs out there wasting a lot of money, but even I'm self-critical in that. Are they really wasting it? No, because what they're doing is they're providing a lot of jobs for people, and these companies are gaining a lot of technical know-how. I personally have had lots of former students start companies and fail. Almost all of them have failed in their first and second companies, but then eventually they learn these hard lessons and then they leave and end up going on to create better companies. They learn the systems engineering lessons, and then eventually we get to the right place. But I just think it's probably a more expensive cycle than it needs to be.
Yeah, let me push on that a little bit. And so in a world of excess resources, let's call it, private equity, venture capital, corporations, where money is earning negative interest, you have an incentive to throw money out of the window. But I would argue that is truly wasting resources. You know, what we teach in business schools is that if you don't have good ideas to fund, you have to give it back to shareholders in dividends or stock buybacks or things like that. But that is not sexy enough for these technology companies, right? They just have to do quantum computing or, you know, the next sexy thing, because they got just billions of dollars earning negative interest. And I think in the long run, this is going to come back and bite us. This is my fear.
Oh, sure. I mean, this is to say, look, I in any of my investments, I tell my broker, do not invest in XYZ because I don't want to waste my money. So I do agree, and I think that we're being set up. I think we're already seeing it right now. I think COVID kind of accelerated some of these problems. The issue of venture capitalists, but it's not just VCs, it's actually even big, well-entrenched companies investing money in technology that has 0% chance of being successful, I think that this is a pandemic. I call it the pandemic of incompetent AI. And it's just amazing to me truly on a daily basis how many obvious, bold-faced, bad investment decisions are being made, and no one is calling companies out. Indeed, I've actually started to get a reputation as a curmudgeon in this space, because I just get tired of it. I get tired of people doing things like, trying to control cars through 5G. It's just not going to happen. It's never going to happen. And so now I start calling companies and, occasionally people out for making claims that just aren't supported by even the most basic of scientific principles. So I agree with you that in the end, it's not a good thing. But I am trying to say there is a silver lining, right? For all the bad investments that are being made, eventually, I think that there's a learning curve that comes out of it. And are we actually making that money back? Well, probably not. I think what all of this underscores is the need for technical competence in education, not necessarily in the traditional four-year colleges, but although I think that that's a huge need. I think that this country needs to spend a lot more time and effort, both in traditional college educations, but also this continuing education for people in companies. The number of people in C-suites that do not know what they're talking about when it comes to technology is another pandemic, right? Leaders who think they know that don't know and won't admit that they don't know. I think that's a huge problem.
Yeah, I think you mentioned this. Do you think there is a disconnect between academics and practice? Again, what I see now is when you get out of undergraduate school, you get 4 of your buddies and you go create an AI company. And all you need to do is to say, I have an AI company and millions of dollars flow in. And so, you don't go to graduate school, you don't pursue sort of the foundational knowledge, one could argue. So do you think there is an issue there? There is a disconnect between academics and practice because of this free money out there?
Oh, huge, huge. And I say this all the time, and I'm not joking. I am never getting into a self-driving car that any of my students have ever programmed. I mean, it's just, I currently have this project. I have this amazingly cool data set that is very safety related. It reads like, a NASCAR crash scene. So it's a fantastic data set. It's thousands of data points, but it's from the real world and it's messy. And I have now been analyzing this data set for over almost 3 years now, and we keep having to start over again because the students do such a bad job at cleaning the data, right? And so like you're laughing, and like every other professor who does anything in any data science related fields knows this problem. Look, real world from the data, like if you look at any transportation data set that is at the federal level, what you're going to get is lots of missing blanks. People put in special codes for certain kind of conditions. The data is not all the same. This is very typical. Data in the real world is messy. And so 90% of almost all of AI is getting your data to the point where you can analyze it with one of these clever algorithms. And students will cut corners, they'll cheat, they'll lie, they'll say they did it, but they didn't do it. And then when you catch them not, I have fired so many students over just their inability to stay into the details and and be happy with this data set. Indeed, it's been such a problem, and it's not just this one project. And professors around the country tell me they're having this problem too. If we can't get people to pay attention and to understand the importance of getting a data set cleaned in the right way, and at least you can document where the limitations are so that you know where the problems are in your data set, I think that students keep quitting and I keep firing them, and they all say, I hate this part. I don't want to do this. I didn't sign up to, I don't know what they thought they were going to do. Like, were you going to sign up to do a data science project and fly fighter jets? You know, I mean, that's just, it boggles my mind how difficult it is for people to have attention on task and do a good job at these data sets. But if I'm having a problem and other professors I know are having a problem, then I'm telling you this problem is also a pandemic through the rest of the community. And I really start to question any big claims that are coming out of any AI model from any lab, from any company. I have serious doubts about, because unless I actually got to look under the covers and see what's going on with their underlying data set, I am telling people, your people are cutting corners, and this problem with data curation, I've actually started to think about teaching a class just on this, because it is that big of a problem.
I want to go into another recent paper on a slightly different topic: lethal autonomous weapons, meaningful human control or meaningful human certification. And you say there has been increasing debate over the use of autonomous weapons in the military, whether they should be banned for offensive uses, and even whether such technologies threaten our very existence. I mean, you have a lot of experience in this area. On one hand, I don't know if it is avoidable, right? I think we will ultimately reach a point of warfare that is completely technology driven, because humans don't like to do that, let's say. On the other hand, what you're pointing out here is that maybe in transition or perhaps in the long run, there are a lot of risks around that, right?
Yeah, I mean, I think it's a nuanced problem, and I am neither for the use of AI on the battlefield right now, but I'm also not in support of a ban. And again, this paper's on my website and you can go read it. I think as a former fighter pilot, and this is where we were talking about human error. Oh my gosh, have I seen human error? Have I made human errors? The fact that I'm still alive, when I think about my 20-year-old self making the mistakes I made in a high performance aircraft, it's kind of scary. But, I survived to tell the tale, and the humans, just by the nature of fatigue and needing to eat and having to go to the bathroom, I mean, there are just some issues with the human situation. And if we're going to do prolonged forms of warfare, why these aren't a good match. So, yes, have we been trying to use technology? Would we rather use technology? As soon as we figured out rocks and bows and arrows, you know what I'm saying? Weapons today, drones are really just another extension of rocks, right? We're just figuring out how to back that distance up and how to have a tool do the killing as opposed to us doing the killing. I am not a fan of killing, but I'm very practical. I'm very pragmatic about this. Look, we're always going to have warfare, and I think that it is human nature to try to distance ourselves from the killing if we can. Now, that being said, I do think that there are some pros and cons to using artificial intelligence. And so one of the things I talk about in this paper is that we've actually had very baby, low-level forms of AI in a weapon called the Tomahawk missile. And we've had that for more than 30 years now. So this Tomahawk missile was able to do basically early computer vision, and its accuracy is eye-watering. It's within a meter. No human is consistently a good bomber within a meter. So when you give the coordinates to the Tomahawk missile, it will get its target always. And the only time there's ever a mistake made is when the human enters the wrong coordinates. So because of that level of precision, and people hear about surgical strike, yes, it is possible for us to only bomb the 7th floor of a 10-story building. So we can be that precise. And if we can be that precise, I would argue under just war theory, we should be that precise. I think the real issue is when people start to associate AI with killer robots and the Terminator, and there's many Hollywood depictions, but even the technology, the weapons that we've had for a long time fall under those same ideas. And so I don't think we shouldn't throw the baby out with the bathwater. In some forms of warfare where you're bombing static targets like buildings, where you can have very, very low uncertainty about the target that you're getting. I am a big fan of using AI, and I think we should use AI because of the propensity for humans. For example, we've had so many cases of humans bombing the wrong target because you're at 35,000 feet, there's clouds, there's smoke on the ground, there's other weapons being fired at you, you're under stress. So if we can remove all that and have the autonomy do it, and with a high degree of certainty, then I'm all for that. I think for me, the real question comes to dynamic forms of warfare. So if targets are on the move, or we're talking about trying to kill a person who's traveling in a truck, there's still so much uncertainty around that. And our vision systems today for dynamic systems are horrible. And I give a couple of illustrations in this paper about just how far away we are from dynamic, being able to do dynamic warfare. For all the same reasons that Teslas are doing a terrible job. I mean, there's just so much uncertainty in the real world when you're moving around in the real world. So I am not a fan of using AI for any dynamic forms of weaponry. Now, that is likely going to change over time, and I don't think we should rule that out. The case that I give, and I can certainly envision it because I have seen this with my own eyes. I have seen a human pilot drop a bomb on a building, and then as the weapon is in flight, and it's too late to turn that weapon around, the building door will open and you see that there's a person in the building. It could be a child, for example, or a medical professional. I mean, and you're bombing and it's happening in flight. These things happen. In the world of AI, humans even remotely controlling a weapon like that from a drone just simply do not have the reaction time to be able to make that not happen. AI would be able to move that bomb off the target and at least hit in a place that's less likely to do damage. And so I can see in the future, there are cases where we may want that kind of technology. My whole point is we shouldn't look at bans on weapons. What we should look at is certification. And if we're going to start having these advanced weapons, then we need to move the point of responsibility away from, for example, the pilot or the military commander who launches it. These people are just following orders. We need to move the point of authority and responsibility back to the designers of the weapon itself. Did they do everything that they could to make sure that that weapon was going to perform as safe as possible? This is not to say that accidents would never happen, but right now the weapon manufacturers are indemnified from accidents caused on the battlefield. I think we're going to have to move away from that, or else, what other lever do we have on companies to make sure that they're designing at least as safe enough as we can get weapons?
Yeah, it's very interesting. One thing you said, let me see if I understand this. So you talked about sort of the human-machine collaboration could be potentially superior to either one of those doing things exclusively. But there are two types of uncertainty, it sounds to me, right? One is after having made a decision to bomb something, you really have no control over further decisions. And there is sort of a timing based thing. So there is still uncertainty, but there's very little further time to change decisions. And machines are potentially the only way we could accomplish that, right? So it's not just uncertainty. It's sort of there's a hierarchy in some sense of decisions that we need to sort of specialize in, human versus machine, right? Is that the way to think about it?
Yeah, I think that to me, that criteria, what is that go, no-go point? So I'm all about human-machine collaboration, but there is a threshold of where there's a point of no return. And so that we actually know what that threshold is. It's called the neuromuscular lag. The fact of the matter is that you are limited by physics in your speed of being able to see a signal in the world with your eyes or fingers or whatever sense that you're using, and have that information communicated to your brain for you to recognize what the problem is, and then for you to then, for example, push a button to self-destruct a weapon. So that threshold is a half a second. And so, we can't ever get around it, right? So if there are decisions that have to be made in less than half a second, then autonomy is the only entity that's going to be able to do that. Indeed, but this is actually why planes, when they're flown by the computer, save a lot of gas, because all the little decisions that are being made about throttle adjustment are happening so fast and so small. They are sub half second, right? And so there are, and indeed, one of the reasons that nuclear power plants are so highly automated is for similar reasons. So in case something is going critical in the reactor, sometimes humans just simply cannot respond. Even if they were paying perfect attention, they can't hit that button in that half a second time frame that they need to be able to push the rods back in and to keep the reactor from melting, right? So I think this goes back to, I hate to keep beating everyone over the head with the systems engineering stick, but this is exactly what I talk about when I mean function allocation. When you start to think about autonomy in your systems, the first question you need to ask yourself is, what's time critical? If there's any decision that has to be made in less than half a second, can my autonomy do it in half a second? Can it wait to at least my human to attend to it? And once you actually understand where your system, whatever you're operating in, is in this go, no go zone, then you can understand how to design the balance between the two. The reason that drones have been so successful is nothing certainly in the commercial world, civilian world, nothing important happens in less than half a second. You can lose engines, flight surfaces can crack, but you still have more than half a second to figure that out. In driving, this is why it has been so difficult to do autonomy in driving. Lots of really, really bad things can happen in under a half a second. And because the autonomy is so imperfect, and we think that we're going to have the driver take control and then fix the problem from autonomy, that's why we're seeing people die.
Mm. Yeah, so I think they call it disengagement. AI throws up hands in the air and says, I don't understand it, human take over. And disengagement is really difficult for a human because you're basically sitting back relaxing, and it's not that easy to take over something. And so perhaps autonomy is more about accident avoidance, that threshold that you talked about, where the human is going to be pretty useless to make a decision. The machine has to make the decision. And that is potentially quite advantageous, right? Sort of an accident avoidance type autonomy, rather than sort of this full autonomous position that we appear to be moving toward.
Yeah, that's right. And indeed, then this is why people think, well, then we should automate driving, because if humans are such terrible at paying attention and we have this neuromuscular lag problem, then we should automate it. And, if we're standing back talking about shoulda, woulda, couldas, I am right there with you. Humans are terrible drivers. If we could fully automate driving, I have a 14-year-old. I don't ever want her behind the wheel of a car. I wish we could automate driving. The problem is that the neural nets that are powering computer vision, these systems are still so very brittle, and they still have so many, not even just edge cases that they can't handle. There are so many clearly repeatable events that they can't handle, that because the autonomy is so brittle, it can't reason in under half a second reliably either. So now we actually have I actually liken autonomy today to a teen driver. We have the autonomy teen driver, and then we have my real teen driver. I mean, that's just a disaster in the making.
Yeah, yeah. I guess it's work in progress. It seems like we are making reasonable progress, though. If you look at last 5 years, it seems like the systems are sort of coming through. You talked about just like at NASA and other places, they use this TRL type sort of categorization for readiness, right? Technology readiness levels. Is that something that perhaps commercial companies need to really systematically think through?
Yeah, so as much as I say these systems aren't working today, I'm not ruling out that we won't get to a better solution in the future. I do think that there's probably a good business case to be made for slow speed, last mile delivery using autonomous vehicles. And the reason that I think that that's going to be a lot easier to do than, self-driving cars that can take you anywhere at any time are that these, small areas can be mapped very well with a lot of precision, and you can lay in a potentially extra infrastructure to make sure that you're filling the gaps of uncertainty. And the vehicles themselves are moving so slow that even if there is a problem, we've known for a long time that accidents less than 25 miles an hour, people both in and outside the car have a substantially higher risk, higher chance of surviving than over 25 miles an hour, right? So as long as we keep things slow, the risk, then our risk calculus goes way down. So there are some possible wins with autonomy coming out, but and this is the lesson that I would give to all companies, not even just in transportation, but in medicine and in finance, any other companies. If you've got some uncertainty out there that is uncontrollable and can cause serious problems, then you need to reevaluate whether or not these kinds of systems are going to be successful, because it's that uncertainty that's going to get you.
Yeah, I really like the sort of a hub and spoke transportation system. So, if we get the public transportation system up to par here, and then, the objective then becomes go from home to that hub where you can get on a public transport, right? So you can get rid of all the cars because all you need is just that local transportation that can be on demand, which can be potentially fully autonomous. Everybody gets a room in their house. You don't need a garage anymore. So there are a lot of advantages if you go to that type of a situation, I think.
Yeah, right. And I'm a big fan of. I wish I think this country has a disaster of a rail system. So we need to completely almost clean sheet how we're thinking about rail in this country. I would much prefer from Raleigh, North Carolina, to take a bullet train to DC. It's totally doable. The rails are in they're there. Unfortunately, the robber barons of the turn of the century, of the last turn of the century, they're still fully much entrenched, and they're not going to let that happen. So. But you could imagine in a perfect world, you could have rails and airports, and then, these last mile cars to like shuttle you back and forth from your rail station to take you to those points that, the public transportation, the areas that they don't service. And that's particularly important in areas like North Carolina, where we have, significant rural population. So I do think that there's some hybrid modes. Unfortunately, it's no secret to everyone. When you look around, the transportation infrastructure of this country is a mess. Our aviation system, the air traffic control system needs a massive upgrade. The regulatory system around rail needs a complete overhaul. The surface transportation, just asking people not to be distracted and to get off their cell phones is not working. We need tougher regulation around driver distraction. And even areas with trucking, like I am blown away by the number of venture capitalists who've decided that self-driving robo-taxis are not a good business model, but somehow massive multi-ton trucks that are moving at 70 miles an hour, somehow that's a more viable business model, that because they can do even more damage, right? So that's not going to happen, right? So I just think we're in a regulatory rut, but it's kind of dual-ended. Like, we need more regulation in some places and less regulation in others, like drone delivery. And I think that's getting better, to be fair to the FAA. But I think we're in this regulatory weird space because these agencies have either A, been ignored, or B, they've not kept up with technology changes. And so this is something I've been very vocal about, is that the U.S. government, all agencies, the Department of Defense, the Department of Transportation, the Nuclear Regulatory Commission, I'm sure Department of Education, people do not understand technology. They don't understand what technology can and can't do. Their Department of Homeland Security, like, it is not that hard to trick face recognition algorithms, but I'm not sure Homeland Security is keeping pace with all the little tricks that people are learning on college campuses. So what this says to me is that this country needs a complete overhaul of the kinds of people that they're hiring, the kinds of training that they're giving these people, and even compensation packages. Why would anybody go work for the government for $120,000 a year when they go work for Google for $400,000 a year, right? So I think that we've got to rethink the importance of at least understanding how to acquire and maintain technology at the government level.
Yeah, so you have a paper on that too, about regulations. And so this is a big issue, right? Regulators are increasingly, as you say, out of touch with what they're regulating. And, proxies from the past or what we used to do 10 years ago are not really relevant. And so are you suggesting that is this incrementally mendable, or do we have to throw out the current regulatory framework and start with a blank sheet of paper?
No, I don't think we need to blank sheet it, not at all. I think that there are some good parts of the regulatory system that are in place. So, for example, as much as I complain about the FAA, the Federal Aviation Administration, the reality is we have a very, very safe system that keeps planes safe, that keeps air traffic control safe. Notwithstanding the Boeing 737 MAX debacle, which had huge problems with regulatory capture, meaning that the FAA was letting Boeing basically do its own thing without anyone looking over its shoulder. Not considering that, which is being dealt with right now. For the most part, the FAA has a very good process in place of working with technology developers from the very inception of technology to really understand. So to understand the technology and make sure that the companies understand the concepts of operations and the requirements that are going to be needed. Unfortunately, for the surface transportation, the National Highway Traffic Safety Administration and Federal Highway and trucking, the problem is that these agencies have been very, they regulate after the fact. They wait until enough accidents have happened, and then they'll get involved. Assuming that everybody's got seat belts and headlights, they will not get involved with the technology until a certain number of people have died. And that's just not going to be effective moving forward. I think what we're really faced with across all regulatory agencies is, and they just don't understand this yet, they are looking at a step change. They are so used to their systems being mechanical, predictable, hardware-based. But now in all transportation systems, there's significantly more software. So without recognizing it, and just it's kind of interesting because it happened very silently, almost overnight. Cars and trains and buses and trucks are now carrying about as much technology as commercial aircraft. and they're not being regulated at all in the same way. And so I think that we as a regulatory agencies in this country have got to understand that there are huge software components. And if you don't have people on your staff that understand software and all the issues that go around software, then what's going to happen is the tail's going to keep wagging this dog, and we're going to keep getting caught with, you know, our proverbial pants down because we don't have enough people on our own staffs that can flag, you know, well, what should software acceptance look like? What should testing look like? What should we be asking from the original equipment manufacturers in terms of showing us that these systems are just safe enough? I'm not trying to say that systems have to be perfectly safe, but we also should be able to demonstrate that we're going to at least not do any more harm than human drivers when we start to introduce these technologies.
Yeah. So in conclusion, Missy, as you look forward 5-10 years, from an education perspective, from an academic perspective, what would you change? I'm thinking, you know, specifically about AI and applications and making it more reliable, more practical. What would be from an academic perspective that you would focus on?
If I was the grand poobah of all of academia, I fantasize about this all the time. Well, the very first thing that I would do, if I could wave a magic wand, is that I would make all computer science education free at the community college level across the country, because I think we need that. I think understanding software and software code it's almost like another language that everyone needs to. They don't have to be experts at it. You don't have to be a hacker, but I would like people just to be at least more familiar with these environments. So I think we should have community college education free for anyone who wants to take computer science classes. I think we need to, universities need to train all majors to have some basic coding ability. I don't care whether you're in liberal arts, engineering, you know, and of course the liberal arts majors don't want to hear this, but I think that indeed the liberal arts majors, you know, they are digital art, for example, is huge and upcoming. So this would actually even help. I think, you know, I'm at a big liberal arts school at Duke University. I see where technology is going, and it can help everyone. It's a tool in a toolbox, right? So why not give people the tools that they need to be successful? Just like learning how to read and write, why aren't we putting coding out there for people to understand the basics and how to at least use the tools, if not invent the tools themselves? And then the next big change I would make, and this is specifically in engineering, including computer science, and I would also jerk up all the journals and make them start demanding this. We have got to start holding academics accountable for the claims that they make in their papers. We need to invest way more in testing and certification and evaluation of our technologies. So if you're going to have somebody come out and claim that their neural net is X% better than somebody else's neural net, then I think we should be not just these carefully curated data sets that you get on Kaggle, for example, but we should start making people use these algorithms in the real world so that they can start characterizing the uncertainty. Indeed, I would start an entirely kind of derivative field, which is a hybrid of statistics and engineering and risk management. Like, how do we start characterizing the uncertainty around the systems that we design, even if those systems are just algorithms?
Yeah, that makes a lot of sense. Excellent. This has been great, Missy. Thanks so much for spending time with me.
I hope it's been helpful.
Thank you.
Thanks.